Now I'm going to explain to you P block elements 15, 16, 17, 18 group elements. Okay. First question, the correct order of acidic strength of oxy acids. Here, which acids are given? Oxy acids are given. Here, chlorine is there. That means chloroacetic acids are given. So, chloroacetic acids, what are those? Here, these are given here. HOCl and HClO2, HClO3 and HClO4. Like that, four acids are given. These acids names, what are these here? It is hypochlorous acid, chlorous acid, chloric acid, perchloric acid. Like that, four acids are there. Which is strong acid? Which is strong acid means in those acids which is having more oxygen atoms. Which is having more oxygen atom, that one is strong acid. Why it is strong acid? Oxygen atoms are having more electronegative nature. Due to their more electronegativity, so acidic nature of the substance increases. So this way, here acidic nature of the substance increases. So which substance having more acidic nature? Here perchloric acid. Why means here four oxygens are there. So this is strong acid. So acidic nature order, if you take it, there we can take it like this. HClO4 is strong acid due to presence of four oxygen atom in this. Next one is HClO3, chloric acid. Next chlorous acid and chlorous acid. Like this you can take it. So answer, what we can take it here, answer C option you can take it. What we can take it, answer C option. Next question. Next one, if I take in, which gas cannot be collected over water? Which gas cannot be collected over? What is that collecting over the water means? Generally, after preparation of gases, we'll pass those gas through water to remove impurities. To remove impurities, the gas pass through water. When we are passing that gas through water, some of the impurities which can soluble in water, those will be soluble in water, remaining coming outside. Remaining gases comes outside. But some of the gases are highly soluble in water, like sulfur trioxide, sulfur dioxide, ammonia, like that gases. Those are having highly polar nature. So that's why that type of gases we cannot collect over the liquid, over the water. And non-polar gases like oxygen gas, nitrogen gas, like phosphine also having polar nature, but very, very less polar nature than SO2. So when SO2 gas, when it is passing through water, there we can get it SO2 plus water, like that H2SO3, sulfurous acid we are getting, sulfurous acid. So sulfur dioxide solubility much in that water. That's why we don't collect sulfur dioxide over the water. Okay, students? Okay. Next, the correct order of increasing oxidizing power is, which is having more oxidizing power. Here what is given in these, halogens are given. So the substance which is easily undergoing reduction is called strong oxidizing agent. We know that in the total periodic table, which is strong oxidizing element means that one is fluorine. Fluorine easily undergo reduction. Fluorine easily undergo reduction and converted into anions. So fluorine is very, very strong oxidizing agent. After that, chlorine, bromine, iodine. So strong oxidizing agent of halogens, if you want to take, that one is this C option you can take it. Which option you can take it? C option. F2, Br2, Cl2, I2. Next question. Next one is H2S. Here what is given in this? H2S is H2S, hydrogen sulfide does not produce metallic sulfide with. Here what are those compounds? If you see here compounds, copper chloride, cadmium chloride, zinc chloride and COCl2, carbonyl chloride, pass gene. Very simple to find out. Why? How? Here first option copper chloride, if you take it, here what is there? Cu is there, so copper sulfide you can get it. First option A, copper sulfide. And C option, whenever you're taking cadmium sulfide you can get it. And D option, if you take it, zinc sulfide you can get it. Y means here copper, cadmium, zinc are metals. So the respective metals we are getting. But B, if you take in, there carbon, oxygen, chlorine. These three are, what are those? Non-metals. These are non-metals. So here carbon disulfide, sulfur dioxide, otherwise what is that? Sulfur monochloride. Like this substance we can get. But those are not metals. So question is, what is the HTS does not produce metallic sulfide with. Which one we have to take in? B option we have to take it. Why means in that B option there is no metal. So answer is phosgene. Carbonyl chloride is answer. Okay. Next question. Next one if I take it. Next one is the ion or group detected by K2HgI4. K2HgI4 is called Nessler's reagent. The practical chemistry, we will use this one. This is Nessler's reagent. Okay, where we'll use means to detect ammonia gas, we are using that one. So this Nessler's reagent, when it is react with ammonia in the presence of base K2HgI4, NH3 and KOH. So when these reacting each other, there we are getting millions base like this NH2, HGO, HGI. That substance we are getting, that is having brown color. So brown color precipitate is forming. That one is called millions base. So when we are adding Nessler's reagent to ammonia, brown precipitate we get. So it is identification test for ammonia. Okay, students, understand? So like that, what we can take in, answer is here this one, ammonium cation. This substance you can take it. Next, chlorine acts as a bleaching agent only presence of. Here chlorine is acting as bleaching agent only in the presence of moisture. Very important question this one. Here Cl2, when it is passing through water, chlorine gas, when it is passing through water, there we will get in chloric acid and hypochlorous acid, HOCl. HOCl is strong. What is that? HOCl, it will undergo decomposition and giving HCl and nascent oxygen atom. This HOCl acts as oxidizing agent. HOCl acts as oxidizing agent, so it can bleaches color material. Bleaching action meaning what is that? Color material is converted into colorless material in the presence of nascent oxygen atom. Like that, color material is converted into colorless material. Color material is converted into colorless material due to presence of that nascent oxygen atom. This action is called bleaching action. To convert vegetables color and organic materials color, we are using this substance. Vegetables color, organic material colors, to convert to colorless, we are using this reaction. Okay, so answer what we can take it, moisture. Answer is moisture. Moisture means what is it here? Water. Next question. Laughing gas. What is laughing gas here? Nitrous oxide. Nitrous oxide is called laughing gas. What is the formula of nitrous oxide? N2O. So N2O, it is having neutral nature. So we can take it answer N2O. This one you can take it. Next question. The correct decreasing order of basic strength is, for NEET exam, like these questions are very, very important. Hydrates of 5th group element, 6th group element, 7th group elements, their orders, increasing order, decreasing orders, very, very important. So correct decreasing order of basic strength. So here ammonia, phosphine, arsine and stibine are given. What we can take it here, in this ammonia structure, if I take it, ammonia structure, trigonal, all hydrogen structure is same only. Now stibine I am taking here H and H, here H, here lone pair. Both are having lone pair and 3 bonds. But which is having large size? Stibine having, this is having large size, this one is having small size. Due to its small size, okay, less volume means electron density much will be there. Okay, this is having 8 electrons, 1, 2, 3, 2, okay, 1 lone pair. Here's 1, 2, 3, 1 lone pair. It's having 8 electrons, it is also having 8 electrons. one lone pair, one lone pair, but it is a small size. This one is larger size one. So due to small size, more electron density. Here ammonia having more electron density, more electron density, and this is having less electron density, more electron density and less electron density. So that's why ammonia is a strong base. So when size increases, electron density decreases, so basic nature also decreases. Due to presence of this lone pair, these are showing Lewis basic nature. So this substance is what is that? Lewis base. So it donates electron pair to electron deficient molecule and forming day-2 bond. And it is forming day-2 bond. Okay, students, understand? Next question. Next one, if you take in the number of POP bridges in the structure of phosphorus pentoxide and phosphorus trioxide respectively. So I am drawing now first phosphorus trioxide. If I take phosphorus trioxide, the structure like this you can take it. If you see this one, this one here, phosphorus structure, this like this you can draw. Here between these phosphorus trioxide, 4 phosphorus atoms, between these oxygen atoms you have to take it like this. Okay, this one. In this case, it is what is the P2O3. P2O3, it does not exist in monomer, that's why it's converted into P4O6 dimer. It is what is it here? Dimer. This one is dimer. Okay, so in that, how many POP bridges are there? A phosphorus trioxide, how many POP bridges are there? See once, 1, 2, 3, 4, 5, 6. Total 6 bridges are there. So answer here 6. Okay, next what is that? Pentoxide, phosphorus pentoxide. Phosphorus pentoxide extension of this structure only. What we have to do means, there we have to put extra of 4 oxygen atoms like this. With the day-2 bonds, extra 4 oxygen atoms we have to put. So there is no change in this structure, only extra 4 oxygen atoms are added with the day-2 bond between phosphorus and oxygen. So this is the structure of phosphorus pentoxide. Here how many POP bonds will be there? Here also 6 will be there. So answer what we can take it? This one. 6, 6 POP bridges are there. Okay. Next question. Which of the following is not a characteristic property of interhalogen compounds? Which are called interhalogen compounds? Which are called interhalogen compound means 2 different halogens, when those are combined together, those are called interhalogen compounds. So if you take here, okay, fluorine, F2 is what is a halogen. So now chlorine and fluorine, when those two combine together, these are called interhalogen compounds. Like that ClF, ClF3, BrF5, IF7, these all are what are those? Interhalogen compounds. What is the difference between these two? Halogens, if you take in Cl bond Cl, there is no electronegativity difference. Both are having same electronegativity. So electronic difference will become here 0, 0. But interhalogen compounds we are taking, here electronegativity difference will be there. Due to their electronegativity difference, these are showing more reactive nature. So interhalogen compounds are more reactive than halogens. So, okay, and here these are sharing electron pair. Here like this electron pair, these are sharing. So these are having covalent nature. So first one is right. They are covalent. Yes, right answer. Next, more reactive than halogens. Yes. Why more reactive than halogens? Because electronegativity difference is there. That's why these are more reactive than halogens. Okay, due to more electronegative difference, so dipole attraction stronger will be there than halogens. So that's why these are having higher boiling point and less volatile than halogens. Higher boiling point and less volatile than halogens. But third option is what is given in this, have low boiling point and high volatile. So this one is wrong, we have to take it. The third one we have to consider as wrong. And fourth one, what is given, quite unstable but not explosive. Yes, quite unstable. Why mean? Due to electronegativity difference, these are little bit more reactive than Okay, halogens. So this one also right. So what is the question? Which of the following is not the characteristic of intrahalogen compounds? C option you have to choose. Next, hypo on treatment with iodine produces. When hypo, what is hypo here? Here hypo, if you take in sodium thiosulfide Na2S2O3, this is called hypo. Understand what is the use of hypo mean? To estimate iodine, how much iodine present in that given solution. To estimate percentage of iodine, we are using hypo. This in this reaction, iodine, sodium thiosulfide Na2S2O3, when it is reacted to I2, there we are getting iodide ion plus sodium tetrathionate Na2S4O6 we are getting. So you can get this one Na2S4O6. Okay students, understand? So this is a reaction here. Next question. Tribasic acid. What is tribasic acid? So basic means the substance which gives okay the substance which gives 3H plus ions in its aqueous solution. Otherwise, the number of replaceable hydrogen atoms present in given acid is called basicity. Tribasic acid means that acid contains 3 replaceable hydrogen atoms. 3 replaceable hydrogen atoms. Now, if you take it, this substance, first what is given? Okay, phosphoric acid given, H3PO4. Here P double bond O, bond OH, bond OH, bond OH. This is the structure of this one. Here, which are replaceable hydrogen atom means hydrogens which are combined with oxygen, those are replaceable hydrogen atoms. So here 3 replaceable hydrogen atoms are there, 1, 2, 3. So that's why it is tribasic. That's why it is what is that? Tribasic. Okay, remaining also we'll see H3PO3 structure. If you see here P double bond O, bond OH, bond OH, bond H. Here very important point is what is the hydrogens which are combined with oxygen, those only replaceable hydrogen atom. Here it's combined with only 2 hydrogens only combined with oxygen, so it's contain 2 replaceable hydrogen atoms. So this is dibasic. This one is dibasic. Next, if we take in H3PO2, it is hypophosphorus acid. In this P double bond O, bond OH, bond H, bond H. Here only 1 hydrogen only combined with oxygen. So this is called monobasic acid. This one is called monobasic acid. Monobasic acid like this. And fourth one, metaphosphoric acid. Here it won't exist in monomer. Generally we will take it here. Okay, trimetaphosphoric acid, like that substance will take in. Okay, we don't draw the structure in these 3, which is tribasic acid, this one. So answer is A option. Answer is A option, H3PO4. Next question. Electron affinity of halogens, which of the following is correct? Which of the following is correct? Here in that electron affinity means what is the amount of energy released when electron is added to outermost shell of isolated neutral gaseous atom is called electron affinity. So here one exception case is there, that is what is that every group second element having higher electron affinity than first element. So that's why your electron affinity order, if you take in, chlorine is having electron affinity order. Whenever you are taking, chlorine is having more electron affinity than fluorine, next bromine, after that iodine. So this is the order of electron affinity. Based on this, which option we can choose? Based on that, the correct one is this, you can take it. Fluorine is having higher electron affinity than iodine. So right answer what we can take it? D option you can take it. Okay students, next question. Next one is the correct order of solubility in water for helium, neon or krypton, xenon is. Here very important thing is what is the correct order means what we have to take in. Here size increases, surface area increases. Surface area increases, van der Waals attractions increases, London forces increases. So the helium, neon, argon, krypton, xenon, these are what are those non-polar gases. These are forming, okay, what is that bond with water? What is that dipole and induced dipole attractions? Dipole and induced dipole attraction, that type of bond it is forming. So which one can show more, that more attraction, more London forces means larger sizer one, which is having more surface area, that one shows more London forces. So which substance more soluble in water? Xenon. So xenon more soluble in water. Next krypton, argon, neon, helium. So right answer this one. Surface area increases. This type of non-polar substance, surface area increases, solubility increases. Okay. So based on that, B option we can choose. Next one. So mixture of concentrated HCl and HNO3 in 3:1 ratio contain. This is called 3:1 ratio of HCl and HNO3. This mixture is called aqua regia. This mixture is called aqua regia. What is the use of this one means? Generally noble metals like gold and platinum, they won't react with any strong acids, strong bases. But here the mixture, whenever you're taking 3:1 ratio of HCl and HNO3, so aqua regia we are getting with this mixture, gold and platinum reacting with each other, and those are forming, okay, platinic acid and auric acid. So we'll see that HCl and HNO3 when we are taking, there we are getting nitrosyl chloride, NOCl, nascent chloride plus water. Like this we'll get in that nascent chloride, when it is reactive with chlorine, there we are getting so AuCl4 minus, when it is reacting with platinum, okay, Cl, okay, this nascent this one, there will get a platinic acid, platinum Cl6, here hydrogen, here -2, this complex having -2 charge, this complex having minus. Here if I put here H plus, here H plus, here H2FI4. So this is called auric acid, this one is called platinic acid. Like that, aqua regia is reacting with gold and platinum. So in this, which substance we are getting here? If you see options, what we can choose here? NOCl. NOCl is place. Okay, so that's why answer what we can take it, NOCl you can take it. Next one, the element. Question is, what is the element which forms oxide in all oxidation states varying from +1 to +5 is. So which element here? Nitrogen. So nitric oxide, nitrogen dioxide, and nitrous oxide, and nitrogen trioxide, and N2O4 and N2O5. In these oxides, nitrogen showing here +2 oxidation state, here +4, here +1, here +3, here +4, and here +5. Like that, +1 to +5 in these all oxides, nitrogen showing. So what is that answer here? A option you have to take it. Which option you have to take it? A option you can choose. A option you can choose. Okay. So this next question. Next question is, the statement of true N3 minus ion is. N3 minus is what is that? Azide ion. N3 minus means this is azide ion. So this structure, if you see, N double bond, N double bond, N. So this here 2 lone pairs, here also 2 lone pairs will be there. And here, okay, positive charge due to presence of extra electron, here negative, this one is negative. This is azide ion. So here middle it is forming 2 sigma bonds, sp hybridization. So this is having linear structure. This is having linear due to sp hybridization. Okay, so here it has non-linear structure. What we have to find out here? True statement. The first what is given here? Non-linear. So first one is wrong. First one is wrong. Next, it is called pseudo halogen. Yes, right answer. Why means here azide ions, cyanide ions, isocyanide ions showing similarity with the halogens. how halides are showing CO's properties. Like that, some of the properties are shown by these substance, these ions like azide, N3 minus cyanide ion, okay, isocyanide ion. That's why these are also called pseudo halogen. These are also called pseudo halogen. So here this one is what is that? This is right here. Second one is right. Next, the formal charge of oxidation state of nitrogen in its anion is minus. So formal charge means each and every nitrogen we have to find out. So this one, this one, this one. Here if you see every element here, it's having minus one oxidation state, middle one having plus one oxidation state, and end one having minus one. But here what is given? Minus one. Actually formal charge is what is that? Minus one, plus one, minus one. So wrong is given. So this is wrong. Third statement also wrong. Next, it is isoelectronic with NO2. We will see number of electrons here. N3 minus and NO2 is given. NO2 only just it is given. Here N3 minus. Nitrogen atomic number what is that? 7. 3 nitrogens 21. So 21 plus 1, 22 electrons. And nitrogen NO2, nitrogen dioxide is given. So here what we can take in 2 oxygens means oxygen atomic number 8, 8 into 2, 16, 16 plus nitrogen atomic number 7. So what we can get? 23. So 23 electron. Nitrogen dioxide having 23 electron, azide ion having 22 electron. So these two are not isoelectronic. So what is correct answer here? It is called pseudo halogen. So here what we have to choose? B option we have to choose. What you have to choose? B option. Next question. Next one. Okay. So the incorrect statement among the following is, okay, here what is given? C60 is an allotropic form of carbon. Yes, Buckminster Fullerene. It is what is the allotropic form of carbon? Right answer. Ozone is an allotropic form of oxygen. Yes, O2 and ozone, those two are allotropic forms of oxygen, right? And S8 is the only allotropic form of sulfur. Allotropic forms of sulfur, what are those? Monoclinic, what is that? Rhombic sulfur. And what is it? Monoclinic sulfur. Next, plastic sulfur. Okay, so these are 3 sulfurs are there. So here S8 is the only allotropic form is given. That's why this one wrong one. Next, red phosphorus is more stable in air than white phosphorus. Yes, red phosphorus is more stable based on their structures. Here white phosphorus is singular entity. This one, it is monomer, single unit will be there. Okay, like this structure will be there. It is P4 molecule, white or yellow phosphorus. White or yellow phosphorus. Okay, so now red phosphorus, whenever you're taking in this red phosphorus, here phosphorus exists in polymeric structure. Phosphorus exists in polymeric structure, like that phosphorus P4 molecules many combine together and forming one long chain like this. So this structure you are getting polymeric structure. This type of polymeric structure we can get. That's why red phosphorus is more stable in air than white phosphorus due to its polymeric structure. Okay, next. Tincture of iodine is, what is tincture of iodine? Having antiseptic nature. Okay, so what is tincture of iodine means? Iodine having non-polar nature. It can soluble in non-polar solvent like ethyl alcohol. So alcohol, when the alcohol solution of iodine is called tincture of iodine. So C option you can choose. Next question. Which two of the following salts are used for preparing iodized salt? What we can take it answer? Well, iodized salt contain potassium iodide, potassium iodide. So 1 and 2 are present in iodized salt. So answer is A option, 1 and 2. Okay, next question. Next and last question, this one. Here, what is the, so HCF6 on hydrolysis produces. In this case, what we can get here, xenon F6, when it is reacted with 1 mole of water, there we are getting xenon oxy tetrafluoride plus 2HF we will get it. When it is reacting with two water molecules of water, there we can get in xenon dioxide difluoride 4HF we are getting. And this substance, when it is reacting 3 moles of water, here xenon trioxide plus 6HF we will get it. Like that, xenon hexafluoride on hydrolysis produces here, okay, this substance, this substance, this substance. But which is main substance here? Complete hydrolysis, which substance is giving, that one we have to take it in this case. So right answer is what we have to choose, xenon trioxide.